Alright, we're in section 8.3 now, and we're looking at how we can use these counting principles to compute probabilities. If you recall back from chapter 7, the fundamentals of probabilities, or whatever it was called, if you have a sample space of equally likely events, and you take the size of the sample space, or you take the size of your event and you divide it by the size of the sample space, then you get the probability of that event. And that's exactly how we're going to be using these counting principles to compute probabilities. If we have 4 letters chosen at random from the alphabet, this is with replacement, so I could choose the same letter multiple times. What is the probability of choosing the letters P, A, R, T? Alright, well, the total number of ways I could do this, well, I could choose, let's see, E. This is the event that I choose P-A-R-T. So N of E, well, the number of ways I could do this, I'd have to choose P for the first letter, A for the second, R for the third, and T for the fourth. There's only one way I could do that. Yeah, there's only one way to do that. But N of S, this one's a little bit more interesting. The total number of ways I could draw, yeah, 4 different letters from the alphabet. Well, this is 4 choices, and each of these choices has 26 different options, since this is with replacement. So you can see N of E over N of S, the probability of E there, would be 1 over 26 to the 4th. And we could figure out what number that is. Gotta find my calculator here. Let me just figure out what 26 to the 4th is really quick. That's 456,976. And if we were to write that as a decimal, I mean, I guess we could do that. 1 over that is going to give us some rather small number, 2.188 times 10 to the negative 6th. I think these probabilities tend to be more useful to look at as fractions in their fractional form, so that's how I tend to just leave them, unless I have a specific reason to write them in a different way.